FastMCP2's task protocol implements an event-driven callback mechanism for asynchronous status monitoring, enabling clients to register handler functions that execute in response to server-reported progress updates. This decoupled observer pattern allows applications to maintain responsiveness while long-running operations execute in the background. We're about to examine a reusable status handler implementation that demonstrates the protocol's callback registration interface and status object introspection. The code will show how to attach a handler function to a task object and process different status states through conditional logic. From FastMCP import client. Def status handle a status. Handle task status updates. Args. Status task status object with. Tasked unique task identifier. Status working, completed, failed, or canceled. Status message optional progress message from server. If status equals working. Print progress status message. Elif status equals completed. Print task completed. Elif status equals failed. Print task failed status message. Task on status change status handler. This code demonstrates a callback-based status handling pattern for asynchronous task monitoring in FastMCP2. The status handler function implements a clean separation of concerns by encapsulating all status update logic in a reusable component. It follows the observer pattern, where the task object notifies registered handlers whenever its state changes, allowing for decoupled progress tracking. The implementation handles 3 key states: working, completed, and failed, with appropriate messaging for each. This approach provides real-time feedback without blocking the main execution flow, which is particularly valuable for long-running operations. The pattern is flexible enough to support both synchronous and asynchronous callbacks, as shown in the broader context where onStatusAsync demonstrates async handler support. This design choice enables applications to maintain responsiveness while monitoring background tasks. The trade-off is slightly more complex code structure compared to simple polling, but the benefit is immediate user feedback and better resource utilization. The pattern aligns with FastMCP's task protocol, where servers can report progress through the progress dependency, creating a consistent client-server interaction model for background operations. Let's break it down. From FastMCP import client. Imports the client class from the FastMCP module, providing access to FastMCP's client functionality for task execution and progress reporting. Def status handle a status. Defines a function named status handler that accepts a single parameter, status. The function signature includes a docstring opener, but no implementation details are visible in this segment. Handle task status updates. Handles task status updates by processing progress reports. This line demonstrates the mechanism for tracking and updating the status of tasks within the FastMCP framework, specifically focusing on progress reporting functionality. The code segment shows how task progress is managed, allowing clients to receive updates on task execution status. Status, task status object with. Tasked, unique task identifier. Defines a status object containing a tasked property that uniquely identifies a specific task. If status equals working. Print progress, status message. Checks if the status object's status attribute equals the string working. When true, prints a formatted string containing the progress message from status message. This conditional output provides real-time feedback during task execution by displaying the current progress status only when the task is actively working. Elif status equals completed. Print task completed. Checks if the task status is completed and prints task completed when true. This is a conditional branch that executes the print statement only when the status attribute of the status object equals the string completed. Elif status equals failed. Print task failed. Status message. Checks if the task status is failed and prints a failure message with the associated status message. The condition evaluates the status attribute of the status object, and if it matches failed, executes the print statement that outputs task failed, followed by the content of status message. Task on status change status handler. Registers a status change handler for the task, invoking the status handler function whenever the task's status updates. This establishes a callback mechanism where the specified handler will be triggered automatically on status transitions. The status handler implementation demonstrates FastMCP2's event-driven callback mechanism in action. By registering the handler function with task on status change, we establish an observer pattern that decouples status monitoring from task execution. The handler's conditional logic processes 3 key states: working, completed, and failed, providing appropriate feedback for each scenario. This approach maintains application responsiveness during long-running operations by handling status updates asynchronously. The design choice prioritizes real-time feedback over simplicity, trading slightly more complex code structure for immediate user notifications and better resource utilization. The pattern aligns perfectly with FastMCP's task protocol, creating a consistent client-server interaction model for background operations.
The task completes before the status handler wakes up to report it.